Yeah, so this is still training, which I think it will be done soon. Um, but what we could do as well is I'm gonna select this to download real quick. Let's see here. Let's do this. If I'm able to, let's see if I can do this. Download. You can do one. Can be downloaded to the console download folder, and then I guess if I'm able to go back to. I guess that would make sense. Yeah, if I select this and activate this Cloud Shell, I should be able to copy these images locally and also simultaneously see if I can get this to work with the CreateML system from Apple. Let's go here, select download, copy this, and then run this. Let's see what this does. We'll authorize it. So this pulls the data the other way, which is now we're going to put it into the Cloud Shell. And then one of the things that I can do is they have a editor here that I should be able, there we go, open editor. And with this, I think this is student 03, yeah. Once you open up the editor, I believe we can go to these, yeah, we can right click and just say download. Let's see if that works. Yeah, there we go. That's pretty nice. So I can actually right click here. So basically, while I'm waiting for this to train, we can also train this locally with Apple CreateML. So we can basically test out another method. So if I go here and I go to download, I can right click on that, and then I go here, I can download. Okay, so I've got those locally. So I'm gonna let this thing keep running, and then I'm gonna just minimize this for a second, and then what I'm gonna do is also minimize this, is I'm going to open up CreateML here. So I'm gonna open up Xcode, and once you open up Xcode, we can right click to open up CreateML. Yeah, so go here, close this, open Developer Tools, CreateML. All right, and then from here, we can actually just say new document. And then again, we can do a similar workflow. So we can kind of compare how the two work with each other. So we'll say image classification, and then we'll call cloud classifier. And then we'll store this on the desktop for now. And then notice again how it gives us this interface. So what I'm going to do is go to the download here, and I'm going to just copy these files locally. There was 3 of them, right, which are right here. And then I'm just going to uncompress each one. There we go. There we go. There we go. So we should, yeah, so we should have 3. I'll delete these, and then I'll just call this clouds or something like this. And then I'll put all 3 inside of this folder. And then I can just drop this onto this. There we go. And we see 3 clouds, auto training. So what's nice about this is that I think I can even just make this large full screen now, is that in a way, it shows how much more convenient the Apple CreateML is to train things. And notice that it says automatically spit from training data. And one of the things that we can do as well is that maybe we can actually see if we can add this data augmentation. So the reason you would do this is that it would make the model more robust in detecting different kinds of scenarios. And so if I add noise, it means that if I give it images it's never seen before that have some noise, it would still be able to do a good job. Blurring, same thing, cropping, exposing, flipping, rotating. And so this has actually features that the Google Cloud doesn't have, and also this is free. So if I click on train, let's go ahead and see how long it takes to train. There's not a lot of images, so hopefully it's pretty quick. There we go. We see that it's gone through and it's trained. It's converged. I mean, that's the other thing that's interesting, is that Google Cloud's taking 30 minutes. So maybe one of the things to consider is that they want it to take a while because they charge you by the hour, right? So they're not necessarily incentivized to make it quicker. And then if we click on evaluation, we can see here's our results, preview. Now that we trained it, what we can do is actually we can find some other images maybe on the internet and test this out. So basically, even though the other model is still training, we can still proceed. So let's maybe put a web browser here, and let's find some images. Let's say Cumulus Cloud. Let's find this images. There we go. Let's download this. We'll say save image. Wait, where did I save that? I said save. No, I'm going to save image as. I'm going to put it on my desktop, and we'll call this Cumulus. And let's try it out. Let's go to here. I'm going to click this plus, add files, Cumulus. There we go, 99% confidence. So it's already working pretty well, and it was instantaneous. So I think there's some issues, I think, with Google Cloud. I mean, there's lots to like about it as well, but the fact that they're doing a demo where it takes all this effort to do all the work, but then you can use Apple's CreateML and then instantly you're able to get good results, is something to think about. Now let's go back here to the preview. Let's see here. What else we have? Cirrus. So let's go ahead and let's find one of those as well. Cirrus Cloud. Let's get it. Let's just get a random picture on the internet. There we go. Let's do this. We'll say save as, and we'll say Cirrus. And then let's go back to preview. Let's click another one, and let's look at the Cirrus Cloud. There we go. It also is able to correctly do this. And then I think the other one was Cumulus Nimbus. Let's go through here, Cumulus Nimbus, and let's save this, and we'll say Cumulus Nimbus. Of course, we can also test these same things when the Google model is finished. Select it, add files, Cumulus Nimbus. Where is this thing? Whoops, desktop. There we go, Cumulus Nimbus. Slightly less confident, but it still is able to detect it. And then again, what's neat about this is that because I've trained this in terms of the output, that I can actually just download this right here and notice that in fact it creates a CoreML model, and this model I can put this on to my phone, right? In fact, one of the things that I'll show you is if you select this Xcode, what's pretty neat is that it'll automatically open up Xcode for you. Let's just wait for it for a second. and it'll pull the model into an Xcode project so that you have the ability to play around with it. There we go. So we see this, right? So it'll actually pull it right into a project for you and kind of get it ready for you to start writing code against it. And then you even can go to the same thing. You can look at you know, like what kind of input it needs for it, how to actually use it, how to preview it. So again, we can just drag images maybe from the desktop. So I'm gonna grab this here. There we go. Right, we can just drag things onto it. So there's a lot to like about how quickly you can use this. And then for utilities as well, you can create a model to prepare your model for something they call CloudKit. And then you can also encrypt your model as well, presumably so that someone couldn't steal your intellectual property. And so there's a bunch of tools here that you get for free, and it even says that the model size is 34 kilobits here, and that we can use it in these different projects. So yeah, I think that this particular scenario here is pretty interesting. So let's toggle back now to the Google Cloud model, and let's see what's going on. So it's still training. And then if I open up this, so yeah, I guess one kind of takeaway here is that I think this shows one of the downsides to the cloud-based training system, is that for maybe quick prototyping, that it may be quicker to prototype a local edge-based model using the CreateML tool or some other equivalent local tool. Where this would come into play, the cloud-based system, is if you have very large data. You know, let's say you have a petabyte of data. Well, your desktop is not going to work, right? Like you can't. It's not even possible to train the data on your desktop. So I think they're potentially slightly different tools here. So I guess actually what I can do while this is training still, because I think it's going to be done in, let's say, 5 or 10 minutes, is I can show you a different account. So I'll just minimize these for a second, minimize this, and I'll show you an account I have, my own Google Cloud account. So let's do that. Let's go into my own personal Google Cloud account, and let's see some models that I've trained in the past. So I'm going to log in here, and there we go. And if we go to Vision, which is right here, let me make this a little bit bigger. Here's AutoML Vision. That if I scroll through, here's a project I uploaded a couple years ago, actually. So it's been around for a while. And this is a little bit more of a complex project. And this project has 3,667 labels. We've got daisy, dandelion, roses, sunflowers. So we have 5 different kinds of flowers. And again, I can inspect these. And as I mentioned before, I think this is really helpful to see that sometimes you do have actually bad data in your system. Like, for example, if we go to tulips, one of the things I think that's interesting inside of here is there are, I thought that there were some bad images inside, like, maybe not, maybe it's under sunflowers. I know there are some examples here of just things like this, roses, like that's not a rose, that's the bad data, right? So it's hurting the accuracy of my model to have that inside of there. And so I as the data scientist, I need to inspect this first and say, hey, why is this in here? And then even figure out how this image even got into my data set. Did I accidentally collect it? or is there a process that's pulling the wrong images in? But it will affect the accuracy. And then if we go to the train here, you can see that when it's finished, which we'll be able to see in maybe like 5-10 more minutes, is that it will give you actually the accuracy and break it down into sub metrics like precision and recall, which essentially show you, in the case of precision, this is the frequency of predictions that were correct, positive. The higher the precision, the fewer false positives. And then in terms of recall, the higher the recall, the fewer false negatives, or the fewer predictions missed. And in this as well, notice that there are two types. There's model type cloud, and then there's also model type mobile best trade-off here. And these are, again, the two different selections here. And that in the cloud situation, this would be if I wanted to predict, and make an endpoint so that people could call my API. Or in the case of mobile trade-off, if we go through here and we select this, see full evaluation, that we could later download this. But for now, let's just take for a second, just take a look at how this works. Once it's done, it'll show me how well each of the labels was able to be predicted, and then gives the breakdown of the recall and the precision, which again is like false positive to false negative. And then it'll give you a confusion matrix as well that shows you all of the different metrics here for it. And as well, if we go to each of the individual labels, that it'll actually go through and show you pictures of each of the classification issues. So here's true positives. Your model correctly predicted dandelion, right? And it shows you all the true positives, and it shows you every single one. So you can also inspect. So there's some things that I think that the Google Cloud platform does give you that's pretty useful. That once it takes a lot longer, but then you get these really good tools to evaluate your data. Also though, look, it will show you the false negatives. So your model, in this case, we can go through here and we can look at all the different false negatives. And then in this case, there's no false positives. Let's see here. In this scenario, false negatives. So your model should have predicted roses. Well, again, we know that that's bad data. So that's something that should be evaluated. False positives, your model incorrectly predicted roses on these images. So this also is really helpful for the data scientist to look inside of here and say, hey, what can we do to improve the accuracy of the model? Because you can visually look at the different categories, false negative, false positive, true positives, and actually see how well the model is performing, which again is part of the rapid prototyping and the feedback loop that will make your ability to create machine learning models more effective. And then finally, under the test and use here, notice that this would be where you would then, after the model has been created, you can actually download the model in one of these other formats. And so the differences here would be TF Lite, TensorFlow JavaScript, CoreML, which is what we just did with Apple, right? So arguably, depending on what problem you're solving, if you are going to use CoreML, we saw if it's a smaller data set, it's probably better to not use Google Cloud, but to just do it with CreateML. If it's a larger data set, it may make sense to use the Google Cloud AutoML. Also container, so you can actually download the model into a container, and then Coral, which we just talked about, right? The Coral, this thing, right? This Coral device, which is pretty powerful. So if I click on Coral here, for example, let's take a look at what you would do. So it would again just download the TF Lite model, and then if we select it, let's take a look at what would happen. So the way you would go next would be you would first need to get one of these products. And so I think this is probably the best one for prototyping is the USB stick. And if we select it, let's see if you can even buy this. Oh, looks like maybe you can. Maybe you can buy this. Let's try Amazon. Let's see if they're available. Nope, unavailable. So I think a lot of people want this device. So there could be some issues there, but regardless, I think when it does become available, this is a good device to get because it plugs directly into your laptop and you can easily play with it. Now, if we go to the technical specifications, let's take a look at this. That you can see that it itself has a TPU built onto it, so the TensorFlow processing unit, and so it's actually specifically designed to work with TensorFlow, so it's very good at doing prediction, and so the prediction speed is very fast, especially if you use USB 3.0. Is that and this is actually another thing to point out, is that if you do care about performance, you want to make sure that you have the correct USB 3.0 cable. A lot of times it's easy to accidentally get a 2.0 cable, even though it's a 3.0 interface. So you would need to have the correct cable and the correct USB 3 port for wherever you're plugging into. And then once it's ready to go, then the next thing that you would do is we could go through here and say, basically, do the installation. So what I typically will do for documentation here is, let's go model compatibility. Yeah, downloads, all software downloads is Edge TPU compiler. Yeah, so typically what I would do when I install this is I would go to here we go, running a model, run inference with Python. This is the part that I would recommend going through. So to simplify development with Coral, there's a Edge TPU compatible TensorFlow Lite API. And so the way it works is that you would need to, depending on what operating system you're in, either Linux or Mac, you would go through and run these installation steps. Now, we may be able to do that. I may be able to do that. Let's see here. Do I have it? I'm trying to think here. Nah, it may not. It may be too complicated to go through this. We may not have enough time, but I'll just kind of briefly show you. What happens is that once you've got this thing running, then this would be an example of what some of the code would look like, is that you are able to use this TensorFlow interpreter and then do some kind of manipulation to it and then invoke it, and then it'll classify it. So basically this thing kind of wraps around their API, and then it will send the predictions to the physical device and let you do predictions on it. So I have actually a whole video that I've done that walks you through how to do this. I can share it in Ed later. But again, if you do want to have, I think, one of the more sophisticated workflows, I think that this Coral device is one of the ones that works very well. The other option here, which I think we can go through, is that I've seen some people do is actually the JavaScript. I think is another interesting one. And with JavaScript, what is kind of neat about it is that instead of necessarily needing to do a device, you could also just download the dict file, the model.json, and then the weight files here. And then once you're done, you could actually write a small web application that uses the TensorFlow JavaScript framework. And then you can see here that once you've done that, you can go through and run a web server that will serve it out. and then test out how the predictions actually work on that. So this is also a pretty neat little workflow, is that if you don't have a device, you can think of JavaScript as well as an edge, because many things can run JavaScript. And so you could create, like, let's say a Raspberry Pi or a laptop or something like this that had a terminal, and it was just doing, basically you could just put things into a folder and it could just be constantly predicting. So let's say, like, for example, if you were a scientist that was working with, let's say, classifying poisonous mushrooms, for example, that you could train a model that classified all the different kinds of poisonous mushrooms, and then you could put this onto a laptop, and then every time you were getting new samples of the data, you could just put those images into a folder, and in real time it would just give you the feedback loop and show it. So I think the JavaScript is another very good one, because the JavaScript performance is very good with TensorFlow. So Google has done a lot of optimization on making that work. So we probably have enough time to go back to, let's go back now to the our model. And surprisingly, it's still training, which is shocking that it's still taking. Let's go back here and see, is it really taking this long to train? Huh. So maybe if I click cancel, I'm kind of curious. You'll be charged for training and your model will be discarded. No, I guess we don't want to do this. Well, the main takeaway is that we already saw what it looks like with the this model, right? Is that's the main thing we care about, is that you can download this model from one of these different locations, and that's really the big thing that is important to take aware of, to be aware of. Now, the other thing as well that we did was that if we go back to the CreateML, that we also saw that probably for smaller data sets, for prototyping, especially if you want to go right to iOS, that this is, I think, maybe the most effective way to build a model is to use this CreateML tool. And then once you've got this CreateML tool, then bring it into Xcode. And in fact, I think I can show you really quickly that Apple has a project. Let's pull this up real quick. Let's see. So if we go to Apple, let's actually pull this CreateML. Let's click on this documentation here. And I'm surprised they've never fixed this. They give you the wrong URL. But see this project right here? I think we can just really quickly get this working. So what's nice about this is that this has a starter kit for you to use the CreateML framework. And so if you look at this, it says with a CreateML framework, you can use a trained model to classify input, etc. You see example, and so then they give you a sample application here, and you can see that there's not a lot of code to do things with it, and then they show you some of the different locations that you can kind of play around with this. And so what we can do is we can go through this and just download this real quick. So let's go, did that download? Yeah, there we go. So this downloaded. So I'm gonna go to my downloads real quick, grab it, here we go. And we'll just minimize this for a second. And we'll just throw this over here. So it gives us this project, we'll uncompress it. And then this will show us that this would be a Xcode project that has the example inside of it. So here we go, Vision and ML Xcode example. I'm going to double click on this. We want to trust this. And then we can see, we can actually minimize this, we can see that this is the full project that we can play around with. And this is, I think, pretty useful to take a look at because it shows you that, look, here's the model, right? That we see it has the ability to detect these different labels of these different animals. And then it breaks in, it even shows you all of the different components of the neural network architecture. And it shows you what each of them are, how many of them: convolution, batch norm, scale, activation, ReLU, softmax, pooling. These are all parts of the neural network that were used to train the model. And then again, what's kind of cool about it is that I can just go through here and preview. So if we went to, let's say, we'll just look at this real quick. Great white. Let's look at tiger shark. Let's find a tiger shark here. Let's open up a new window real quick. Tiger shark. Let's find this. Here we go. This looks good. And let's click on it. And let's save image as onto the desktop, tiger shark, like this. And then we can go to preview again, and we can select this plus, add files, tiger shark. There we go, right? So what's pretty awesome is that they did all the work for us, in that they already have the model trained, plus they put the code together that allows us to use the model. So how would this work? If we go to the Swift code here, we can go to appdelegate.swift. Let's take a look. You can see this basically makes sure that the UI is kind of wired up. And then here's the controller that handles the different pieces of code here. So we can see it says let model try CreateML model. So this says this generates from the model, and it basically has some error handling that says, you know, whether it's able to load the CreateML model or not. And so it doesn't look like a lot of code. It just mostly looks like error handling, and then also the ability to I think work with the camera. I think this is what this does, is it lets you select the camera. And then I think these are just property orientation extension here. So the main work is this controller does basically everything. And now and then if you look at the storyboard, we look at this real quick. I believe this will show us just the way the UI works, right? So it gives us like a UI overview. And so now what we can do is, if we click on this icon, notice it says iPad Touch 7th generation. That's the target. And we can just click this icon here, build, and then run the scheme. And this will compile the project and allow it to run here. And then it should launch into the simulator, which is right here. So now we got the simulator, and it's now cranking. Yeah, what's great again about the Apple project here is that it allows us to really easily test out a full working system. And then we could even take this project and plug our iPhone in, and you could just take it without changing anything and then deploy right to your iPhone, and then even have this running on your physical device. And so for a student project, I think this is a really good interface. And if we go to adding a photo here, we can select this. There we go, add a photo, select this icon. And I think that we can, yeah, we can just select one of the existing images here, and you can see kind of how it works, and its ability to change things. So again, if I wanted to then kind of get rid of this simulator, let's see here. If I go to this is what it would look like on your phone, but I also could tell instead of this, we could actually, it might be hard to see from here, but basically you can say, I want to run and build it even as a Mac application into, use Google Cloud, train it using their cloud platform. The nice thing about these approaches is if you don't have an iPhone, one is you could either use JavaScript, you could use a device if you've got a device, or I've seen many students do this, is Android works very well for building computer vision models, and in particular that you can train a model from AutoML Vision Edge and then export that device using a quick start here, right? Dict, model, TF Lite, and then go through here, set up an Android project, and then test this device as well in a very similar way to what the Xcode does. And again, you'll get a device. So I've seen probably hundreds of student projects use both iOS or use the Android as the target. And really, in your scenario, you don't need to write any code. You can train your own model if you want, but it's pretty straightforward to just use one of these AutoML tools. And I would encourage you to maybe focus on AutoML, just because that it allows you to rapidly prototype what you're building versus maybe spending too much time just on the model. And then once you've got your system working and you have a prototype, you can always make it more complex, potentially by using, let's say, transfer learning or some other approach. But to just get it working, I think that's really the point of this course, is to go through and build a working prototype quickly so that you're able to kind of build things with it.